Hello developers, let's get developing. So today we're gonna actually solve our already solved task, day 6 of the Advent of Code 2023. So we did some work on it and we solved it with a totally brute force approach. So we have 50 million things to check and we're checking all the 50 millions of them, and it's not too slow, but it's not fast. So this works. What we can do now is actually update it. I'm not gonna touch part 1 because part 1 is literally fast enough. In some cases, if we have small inputs, it might be better to actually do a linear search because most of the techniques that involve some kind of a weird searches that are much faster are more complicated than the small dataset searches. So we will complicate the code at no appreciative gain. So, but for the 50 million, that actually makes sense. So I will comment this out and make another method here. Actually, what we can do. One thing that we should notice that just by logic and thinking about it, let's look at the answer. So we have 0 seconds, 0 meters. I'm going to use seconds and meters, forget all the milli stuff. It just scales basically. So 1, 6, 2, 10, 3, 12, 4, 12, 5, 10, which is the same as 2. And then for 6, we have 6, which is the same as 1. For the 7, we have 0, which is the same as 0. So one thing that we can deduce from this, and actually it can be proven analytically, but we're not going to do that, is that this curve is actually a parabola and a symmetrical parabola. So if we have the value here, we will have the same value here. And the biggest value will always be in the middle. So we can always say that the middle value will be a part of the result. So, and which means that the middle value is the part of the result set. And then if we go, let's say, toward the beginning and try to get the first value when we hit the record, so then we can just find the difference between the middle and use that twice. So this, let's explain it on an example. So we have 9 here. As long as we hit 2, and we know that the maximum will be for 3. Okay, these are small numbers. But if we hit 2, if we get these two values, this number, that means there are two values on this side of the parabola and two values on the other side of the parabola. And those are 4 and 5. So as soon as we get that 2 is bigger than the record, the answer can only be 4 for this thing, because those will be 2 and 3 and 4 and 5. Same for all the other ones. Same for 30 and whatnot. So we're gonna assume that in the middle we have a better value. Of course, otherwise the result is just 0, and since we're multiplying, it's gonna be 0. And if the result of an advent of code thing is 0, then a lot of people might just guess the result. You don't need to calculate a 0, it's 0. So I'm gonna say, let's actually we'll add a single method because we might need to do this. Get distance, not get distances. That gets a time and a record, and then no, it will be much simpler. It returns time times that? No. I don't know. Get the distance for a given time. Actually, we need two times. We need total time and button time, which is also a number. So it will, for a given time, total time, and for a given button press, it will give us this thing. So it will basically be this, but just in a function form, because I think we will need to write it a few times. So we will have total time, no, the button time. How much time did we press the button? That's the speed. And the total time minus the button time is the actual difference. I'm not touching part one. We can reuse this in part one as well. So we're gonna get the top of the stack, so to say. And the top of the stack will be at time index that is exactly half of this. Since JavaScript is weird, this won't be an integer, so I will do a mat floor. Actually, it should be mat seal. Because for even numbers, and here's the weird part, if we have 9 numbers, then we may have 10 positions from 0 to 9. If we have 40 numbers, we have 41 positions. So actually for 9, the maximum index is divided by 4.5. No, it's going to be floor because we need the 4. And for 20, the maximum will be, for 14, the maximum will be 20. So we need floor here. Those kind of simple difference cases can make a lot of difference in the actual search. So that is why I don't recommend using this if you have no idea what you're doing, because you need to think about lots of details and it will look much worse than basically this code. This code is straightforward and functional and slow. So we are saying the top is at the half of the thing, the bottom is at that. And now, well, a proper binary search will say, well, top is bigger than bottom. Because we're gonna move the things around, move them closer and closer to get to the task until we get them to be on the same place. And if the same place, we have the solution. However, I don't really trust myself that much with indexes. So I will use another technique that says, well, top minus bottom is bigger than, let's say, 5. And we're gonna loop. And yeah, we're gonna do exactly this, I guess. So we're taking a middle point that is midway between the top and the bottom. So if we're starting with 20,000, we're checking at 10,000. If we're starting with 50 million, we're checking at 25 million. We're getting the distance for the middle. Yes, that we have the actual time and the middle. If we are in the record area, because we are assuming that this is in the record area and this is not in the record area. So we need to find when that switch occurs. So if we are in the record area, we're moving the top down. If we're not in the record area, we're moving the bottom up. So all the time, the bottom will not be in the record area, the top will be in the record area. And then we get to a 5-point thingy, let's say 5-point interval, where we know that the bottom is lower than the number we need, lower or equal, and the top is lower is bigger or equal than the number we need. So we just need to check those 5 values. So now we're gonna do a linear search. And after the binary search, we're gonna do a linear search. and it's only 5 items, so my up to 5 items, so we can literally check them one by one. So I will do some kind of a while loop. So while, yeah, I don't like minus minus, I'm gonna go the other way. So while the bottom is less than the actual record, well, increase it. I kind of think better with +1 than with -1. So when this while finishes running, the distance will be bigger than the actual record, and that will be the first such instance. So inside the bottom, we actually have the first value when we break the record, the lowest possible value when we break the record, which means that we have bottom -1 values that don't break the record. And since it's symmetrical, we have them at the very start and at the very beginning. So how we have twice that many numbers. We have that many numbers that don't actually break the record. And now we can just subtract them from the actual time. I have an inkling that we might be off by one, but I have no idea in which direction. Let's run it on the small input. For that, we wanted to find what number? 71503. So this is both binary, but also a bit of linear search because we don't want to have an off by one error sometimes. We might have some kind of a rounding thing because JavaScript is not terribly precise. And to be honest, it's not much slower because a linear search of 5 items is up to 5 items, and a binary search of 5 items is up to 4 items. So it's not a significant difference, and it seems that we got an off by one error. I'm gonna check this on the bigger input, and you can see the speed of this is a bit less than 4 seconds. It's 4 seconds less than 4 seconds. And we got 400. Let's check whether our actual value is, yes, it's the same thing but ends with 0. I think we're counting something twice, or we are discounting the or both those numbers are even and we're not counting the peak, most likely. No, this is an odd number and this is an even number. So most likely we are missing the 0. We're counting the 0. Yeah, because we start at 0, we don't have 40, we have 41 cases. So we need to take one of them out as well. Let's see. Now when we added the -1, the result is, did we add the -1? We didn't save. Yeah, the result is totally correct, and the total running time, I can get it faster, is between 0 and 2 milliseconds. So this is quite okay. Now when we run all of them, I think the task 3 had some inefficient code that I already mentioned as inefficient, but it was not terribly inefficient. So yeah, right now task 3 is part 1 is taking 75% of the whole runtime, but the whole runtime is a quarter of a second. So we're fine for now. So don't forget to click the buttons and keep developing.